Okay, this is question number 12 from our shadow paper. And first of all, we've got a show that. And then if we notice after the show that, there seems to be something quite similar. So this is quite common in the real papers. So the idea is going to be that we're going to sort of substitute this result in and do some solving a little bit later. So keep an eye on that when you are doing trig. You tend to show something because then you're meant to substitute in that result. Right, what have we got then? So we've got 1 plus cos 2 theta. So that's a special one, isn't it? Because there's some rules. And it should be this one here. So I'm going to try proving left to right, but a trick that I'm going to do is I'm going to just kind of write in terms of sine and cos where the answer might come from, if you like, because this helps give me something to look out for while I'm doing my proof. So I'm looking to make something like this from the left-hand side, because that will mean that I've only got one step left, if you like. So it's a bit tricky with cos 2 theta, because for cos 2 theta, there's multiple versions you could use. You can use cos squared theta minus sine squared. You can use, so 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. So I'm just thinking about which one here might suit me best, because there's not a lot to go off on the left-hand side. So in theory, any of them should work, but I'm going to try, like I said, I don't think there's a lot to choose from here, so I'm going to go with, let's try 2 cos squared theta minus 1. Yeah, let's try 2 cos squared theta minus 1. So if I did that, I would get 1 plus 2 cos squared theta minus 1, which becomes just 2 cos squared theta, doesn't it? Now, what on earth are all these different bits that I'm supposed to make? Let's just check that it actually kind of works. Yeah, can you see it does work, doesn't it? So I suppose this is a bit of a weird one, but it's to be expected with these questions that are generated. So why don't I just sort of say then that this is the same as, I'm going to say this is the same as 2 cos squared theta over sine theta times sine theta. And then I'm going to say that this is the same as, where do I want that to? I'm going to say this is the same as cos theta over sine theta times 2 sine theta cos theta. And then, as we already know, that is the same as that. Okay, so you could have proven it the right-hand side. In all honesty, doing the right-hand side to left-hand side was probably more natural here. But you should, in general, just do one side to the other. But what you're seeing is that if you do one step backwards to the side of your paper, it is helpful for sort of directing what you should do. Anyway, we've done that. And what's the idea of that? Well, when we look at this box, we hopefully notice that if you change the x to a theta, it looks like you're meant to sub in this result here. So let's do that. So 3 plus sec squared x, 1 plus cos 2x. Right, so the question's suggesting to us that if you sub this in, that it might be helpful for answering this question. So let's have a go with that. Right, okay, so it looks like there is something in it. The first thing you notice is we have sine 2x on both sides. Do not just divide everything here, okay? In fact, if you want to really kind of explain what's going on, you could move everything to one side. So let's actually do that. So 3 plus sec squared x cot x sine x, sine 2x even, minus 2 tan squared x sine 2x is equal to 0. Well, now I've done this, what you might reasonably end up doing is saying that you can factorize out the sine 2x. So why is this important? It's important because you've got to recognize that sine 2x could lead to solutions. Okay, like we'll just try this for example. If the x is a 0 here, doesn't this work? Because sine of 0 is 0. 0 times this bracket is 0. So a solution is something that makes the equation work. So there are some solutions from here that people would often neglect. What would this leave though? This would leave 3, is that 3 plus? Yes, 3 plus sec squared x cot x minus 2 tan squared x. So the idea is that now we should kind of work with this blue bit, because this is the bit that could be equal to 0, yeah? But this whole thing here could also be equal to 0. That could be how to solve the answer. So we're going to carry on now with this 3 plus sec squared thing. I'm just having a quick think about how I might want to work with this here. Well, let's expand the left side first, I think. So let's do 3 cot x plus sec squared cot, okay, plus sec squared cot, sec squared x cot x minus 2 tan squared x is equal to 0. Now cot, let's just think about cot for a second. So cot is cos over sine, isn't it? Yeah. If I multiplied this by tan, yeah, so if I did cot times tan, what would that mean? Well, there's cot. Tan is this, isn't it? So can you see that when you sort of multiply both sides by tan x here, this would turn into the following, wouldn't it? It would turn into 3 plus sec squared x minus 2 tan cubed x. Now notice this question said you may use a calculator technique to solve a cubic. So this question's resulted in a cubic, which is not ideal, but we've been told that we can solve this on the calculator. So I think I'm almost there. Sec squared, how to handle sec squared? Well, there's an identity with sec squared in there, isn't it? So what's the identity? Identity is that 1 plus tan squared is equal to sec squared. So I think I want to use this, and then I'm pretty much ready to answer, yeah? So what should we say? We're going to say that sec squared is 1 plus tan squared. So I'll do 3 plus that minus 2 tan cubed x. And then this is going to give me a cubic in terms of tan. So there's a 4 there. If I move everything to the other side, I should get 2 tan cubed x, just to make it positive, minus tan squared x minus 4 equals 0. And then you can solve this. You can solve this to get some solutions. Okay? I think in the interest of time, I'm not going to solve this particular one. But what you would do is you need to be checking, wouldn't you, where it was true for those values. So as long as it's a real value, that's okay. The other thing that you would have to do on this question is sine 2x. You need to be thinking about how you're solving sine 2x as well. So sine 2x is a sine graph that is going a little bit more quickly than usual, isn't it? So when is it going to be equal to 0? You're going to get answers like this as well, okay? So off the top of my head there, I think you'd be looking at 0, pi over 2, 0, pi over 2, minus pi over 2 by the look of it, okay? And then from here, this is a cubic, so you would put it in a calculator and you sort of solve it in the typical way to get some answers for tan as well. Yeah, and that should sort of take care of it. So the emphasis of this question really is on the skill of showing that. So things I'd encourage you to kind of pick up from it would be, First of all, about doing one step before to see where things are coming from. I find that's very, very helpful, but then I still try and prove from left to right or right to left. And then this idea that using your result in part A to part B is supposed to simplify questions. Now, of course, this is a cubic with tan, which is a little bit non-standard, but this is a AI generated question. So I think it's done pretty well, really, going from A to B there. So I hope you found this helpful.